This lecture is on the golden rectangle. You recall that phi is equal to 1 plus the square root of 5 divided by 2, which we know is an irrational number, and we can give the first few digits of its decimal. It is approximately equal to 1.6180339, and in an earlier video we looked at this number out maybe even 20 digits. But it's non-repeating, it's an irrational number. You know that now also because you know that the square root of 5 is irrational. Before I define the golden rectangle, I'd like to just review for a minute how we met phi in Chapter 2. We looked at the Fibonacci sequence, and at one point we looked at ratios of a Fibonacci divided by the one before it. And then we looked at F3 divided by F2, and we continued in that way. We looked at like F11 divided by the one before it, the 11th Fibonacci divided by the 12th, and we went out, and I think the last one we looked at in our lecture video was about F25 divided by F24, Fibonacci's divided by the one before it. And we saw that these numbers, as n got big, this ratio f, the n plus first Fibonacci divided by the nth Fibonacci, as n became large, this ratio tended towards, or became very, very close to, this number right here. And in fact, the further we went out, the more digits of phi came into the ratio. So we say that the ratio of Fibonacci numbers divided by the one before it, or the ratio of successive Fibonacci numbers, approaches the number phi, the irrational number phi, as n approaches infinity. So keep that in mind, that the golden number phi is very much associated with the Fibonacci sequence. So now let's define the golden rectangle. Actually, the definition is right here. This is the definition. So this is something that you need to know exactly what is a golden rectangle. It is a rectangle where the length divided by the width is exactly phi, 1 plus the square root of 5 over 2. Now we're going to be doing our work with calculators, so we're not going to come out with the precise value of phi, but you can assume that if you put something into your calculator, a length, and you divide it by a width of a rectangle, and you get 1.618, you can assume that that rectangle is golden. And before I go on and show you a couple example problems deciding whether rectangles are golden or not, I'd like to mention something about scale. It doesn't matter what unit of measurement you use when you are deciding if a rectangle is golden. For example, these two rectangles look to be identical. Let's just assume they are. And let's assume that the unit here, well, the unit on the lower one, since its width is equal to 2, we see that 1 is, we chose to use a measurement that we let our unit be that long. Well, up here, we're calling the width equal to 5, and so let's see, maybe 1, 2, 3. So our unit is about that long. It doesn't matter what we consider our unit to be. When we divide length by width, notice if we divide 5 plus 5 times the square root of 5 over 2, and we multiply that by 1/5 or divide by 5. Then we have 5 times 2 or 10 in our denominator. And the 5, this becomes 5 times 1 plus the square root of 5 over 5 times 2. And what do we have? Phi. Here, notice, if we decide to call the unit measurement half of the width, then, oh wow, length over width is easy here. 1 plus the square root of 5 divided by 2, and that is phi. So if you know that a rectangle is golden, go ahead and just assume that it is of length 1 plus the square root of 5 over 2, and that your unit measurement is then half of the width. You'll see why this comes in very handy when we do the next problem. Something very special about the golden rectangle is that it is the only rectangle. Remember, length divided by width is equal to phi. It is the only rectangle that you can cut off the largest square possible, and the remaining rectangle is of equal proportion. In other words, the white rectangle here has length over width the same as length over width in the larger rectangle, which we know is phi. So let's see, let me call little l this, and this will be little w. And so really what we're saying here is that the length divided by the width of the big rectangle is equal to, after we cut off the largest possible square, this one, a w by w square, that the rectangle remaining, that the longer side divided by the shorter side, length over width, is the same. And if we're starting with a golden rectangle, then, of course, that length over width is phi. So let's prove this. All right, so now we want to prove it. Notice I took off here little l and little w because we know that big L over big W, this is what we're given, that the length over width of the big rectangle is phi. And I want to show that the length over the width of the smaller rectangle remaining after you cut off a w by w square is also phi. Well, I'm going to just say I know that the big one is golden, so I'm going to call big L 1 plus the square root of 1 plus the square root of 5, and I'm going to call W 2 for my proof. In other words, all I'm doing is just saying I want to use as my unit, I want this right here to be 1. It doesn't matter what scale I use, so I'm going to choose that one. This is just so the proof is easy. You don't have to use algebra to do it. Okay, so now we need to figure out the dimensions of the remaining, the smaller one. So we need the width and the length. Well, the length is easy. This length here, I'll go ahead and call it little l, but we don't really have to. It's obviously 2, right? It's the same as the width of the large one now is the length of the smaller one. So this is the only calculation I need to do. I need to find out what is the width of that little rectangle. Well, clearly it's going to be the length of the larger one minus that distance there, which is 2. So we're going to have the width is equal to 1 plus the square root of 5 minus the part that we cut off. Well, that was 2. So this is 1 minus 2 is -1, so let's just write -1 plus the square root of 5. Or if you prefer, you could write the square root of 5 minus 1. Either way is fine. So all we have to do now is just calculate length over width. Little l over little w is equal to, the length was 2, the width was the square root of 5 minus 1. And now I'm going to put this on pause and put it in my calculator and see what we get. And this is what I got in my calculator. 1.618033989, and I know that my calculator only goes out to 10 digits, so this is what I got. It's close enough for me, so we will say that the length over the width, the little l over the little w, the length and width of the smaller rectangle after cutting off the largest square possible is indeed phi, and therefore we proved it. So let me just recap. If you are trying to prove that some rectangle is golden, what you want to do is ask yourself, what am I given? Here we knew that the larger one was golden, so I immediately labeled that with length 1 plus the square root of 5, width 2. Then I looked at the rectangle I wanted to prove was golden, and I figured out its dimensions, its length and its width, based on what I chose for the larger rectangle. I divided, I came out with phi, the rectangle is golden. Okay, so here I'm just going to do one problem for you, and you'll have some in your in-class problem set to do, and you'll use the same strategy. Take a golden rectangle, I drew one there, and draw the largest circle inside it that touches 3 sides. So this will just be a sketch, but this is what you do. First you draw a big rectangle. Oh, and they said it was golden, so why don't we just say right away 1 plus the square root of 5 will be its length, and its width will be 2. So we're setting a unit length for ourselves, which makes no difference. Now it says a circle touching 3 sides, so it would be tangent here too. It's kind of hard to do this on. It's not going to look very good, I don't think. And not bad. All right, so that's what best I can do on this tablet. I draw a circle. It touches the rectangle on 3 sides. So really I only had 2 choices. I either had to draw it on the left side of the rectangle or on the right. Okay, so if we connect those 2 points where the circle touches opposite sides of the rectangle, if we connect those 2 points with a line and then cut the rectangle into 2 pieces along that line, will either of the 2 smaller rectangles be golden? Okay, so let me take another color here and say here are the 2 points on the rectangle on opposite sides where the circle touches, and I am going to cut down that line. And we are now asking, is this rectangle here golden, or possibly is this rectangle here golden? And we have to decide by doing exactly what I did in the last proof. Okay, well our unit is 2, so if we take the purple, I'll just do it in purple so you'll know we're calculating for the smaller of the 2 rectangles. I know that its length is equal to 2. Its length right here, the length of the purple line segment is 2 because it's the same as the width of the big one. Now, the important thing on a circle is its radius. So if we set this width to be 2, what is the radius of that circle? It's 1, isn't it? The radius of the circle is 1. Call it r. Okay, so the circle, that means that this distance is 1, this distance is 1, this distance is 1. Any distance from the center of the circle to a point on the circle is 1. So that tells me that this distance right here, the width, is 1, because a radius comes out from the center and touches, in fact, the circle and the rectangle right there. So that is equal to the radius, and that is 1. So that's our width. The width is equal to 1. We take these, we take the length, and we divide it by the width, and we get 2, and that is not phi, and so the small rectangle, small, is not golden. If we got phi, it would be. We didn't. Okay, well, let's look at the next one. I can guess ahead of time that it's not going to be because we didn't cut off a square, did we? But let's I'll go to green and do the calculations for the larger one. This distance right here, oh, I thought I was doing it in green, excuse me. This distance right here, we need to calculate that. So that is equal to, well, it's the length of the large one, 1 plus the square root of 5, minus this little piece here, which is 1, and that is the square root of 5. And the square root of 5 is a little bit bigger than 2, so this would be the length. I'll call it big L just to give it a different name. And the width then is the smaller, so the width is 2. So W is equal to 2 for the larger of the two rectangles. And we get then the length over the width is the square root of 5 divided by 2. And if you plug that into your calculator, you won't get anything close to phi. So the green is also not golden. Neither of the two rectangles are golden.